Hello everyone! In this tutorial we are going to learn how to create and play around with Vellum Softbodies inside Houdini. You will see with only 3 parameters we can change our Softbodies behaviors, and it is pretty easy to start playing around with Vellum. But before we start, I want to talk to you about Doxia's Patreon page. If you want to start learning Houdini, Unity and Redshift, check out our Patreon page. We have dozens of tutorials for you to get the hang of Houdini, and plenty more will come during this year. We are going to start a new series of tutorials about rendering in Redshift and in real-time render within Unity. Plus, you get access to project files and to our Trello board, so you can be updated with our roadmap and know what content will come in the future to our channel. With your support, Doxia will be able to keep doing these tutorials to help you and the community to get along with Houdini and Unity. And do not worry, you are always in complete control. You choose the amount you want to pledge, and you can cancel your support at any time. So if you like Doxia's content and want to know more and learn with us, don't forget to check out our Patreon page. The link is down below. I hope you enjoyed this intro, but now let's start this tutorial and play with Vellum. Okay, let's start exploring our Vellum Softbodies. Let's place a sphere. Let's dive in, change this to polygon so we can control the frequency or the resolution, and let's place a transform. And let's move it up 4 units, okay, in y-axis. Let's place a null just to have this everything organized. Let's call it base geo. Okay. So let's go up, and with our sphere node selected, let's go to Vellum tab, and here it's called the Vellum Strut Softbody. We are going to use this one and not the balloon, because we are going to explore a few constraints and then inflate our spheres. So with the node selected, let's press Vellum Strut Softbody. It will create some nodes for us. Okay, let's go up. So we have our sphere, right, the base geo, our DOP network, with a few nodes that Houdini created for us. And then we have let's call it the export node, where you will have your simulation here with your geo, and then a Vellum import, Vellum IO, okay, import and output, and then the Vellum post process, where you can subdivide and smooth your geo. But first, let's go up. Inside the DOP network, you'll see we have a Vellum object. Okay, this is similar to a PopNet or a fluid simulation or Pyro. Okay, so if you already know the other systems for simulations, you will understand pretty easy this one. Okay, so we have the Vellum object, Vellum source, that we are going to get to subpart the geo and the constraints, a merge, and then a Vellum solver where the magic happens. Okay, then we have the merge and the gravity. To start, let's place a ground plane on collision's ground plane, and let's see what we got. Let's press play. You see our sphere is going down, and you see it's kind of bouncing with a soft body module. Okay, zoom in so you can see a little bit better. Pretty cool, right? So we have our first Vellum animation. Pretty easy. Okay, I'm going to hide the ground plane because I don't like it. So we have our sphere. So now what can we do to change our geometry behavior or our sphere behavior? So as you can see, by using that node on the Vellum, it created for us 2 nodes, right? The Vellum constraints, where you create and transform your basic geometry into cloth, right? with a few parameters. And then a Vellum constraint that is going to make how can you say? These Vellum constraints will transform your cloth into something else. In our case, we are using struts, so it is creating a lot of lines between the points, right? And this will help our simulation to keep the basic form, okay? If you see, I can decrease this. You'll see that white lines, those white lines are starting to disappear. If I increase this, you can see I'm getting more and more constraints. And this will keep the sphere from going inside, okay, or going outside to stretch. Okay, so basic stuff. If we want to change the behavior of our sphere, we are going to explore the stretch stiffness, the Vellum max strut length. Remember, those were the white lines, the white guidelines to control the behavior of your soft body, and then the stiffness. Let me increase a little bit the size of our sphere on the transform better. Okay, nice. So we can see a little bit better the white lines. Okay, so I'm going to explore some parameters with you. So let's change this a little bit. Let's place the null above and then the transform. So because I'm going, so you can understand a little bit better what we are going to do, I'm going to multiply this, copy and paste, so we can see what the parameters are doing to our simulation. So we have the basic ones, okay? Let's do this. With the Alt drag, you can copy paste the nodes. And let's move this a little bit to the right. To have this new sphere with the Vellum to the simulation, let's do a little trick and combine everything together. So we have a merge to the geo null, okay, so let's write this in. And we need another merge for the constraints. Okay, so basically we are creating a sphere, right? We are using 3 nodes to move the sphere and then transform to cloth and so soft body, and then merge those geos with a merge into our null, and then merge all the constraints and then export to the null. Okay, so this geo null has every geometry, and then this con, its constraints, have all the constraints we need for the simulation. I'm jumping ahead these 3 dots because if you have already seen any Vellum tutorial, every single one explains these 3 dots, these 3 inputs and 3 outputs. Basically, it is the input for the geometry, input for the constraints, and input for the collisions. In our case, we are just using the input and output of geometry and constraints. Okay, so the first one is the basic one. Okay, on the second one, we are moving 6 units to the right our sphere, and let's play with this one. Let's make a really soft body, kind of like a cloth. Okay, so let's play with this. We can see on the first one we transform into cloth. We have our stiffness on the higher one. Let's decrease this to 100. Okay, so this is doing 1 verse multiplying by this number. Go to 100. And on the Vellum constraints, let's change the max strut length to 1. So we have fewer white lines. You can see the difference between these ones, right? And then on stretch, stretch chance is really low, kind of like 1 and 1. Yeah, that might look cool. Okay, so let's see the behavior. And you'll see the difference between this one and this one. You can already see difference, right? Because on this one, we have a lot more constraints, so it is keeping the sphere almost with the original form, right? Pretty cool. Let's explore another one. So basically, after a while, you get the hang of the parameters. But to start, I like to do this. Just keeping adding spheres. Remember, connect this to the merge. Let's change again the cloth theme. Let's change maybe this one. Instead of 100, let's decrease a little bit to 60. Okay, on Vellum constraints, I think I won't change anything. Maybe, let me go to con. We had a little bit of guidelines. Okay, 20, that looks cool. Okay, let's see the behavior of this one. And as you can see, by switching only a few parameters, you can get really different results. This is more like a rubber. And because we have more constraints, after it hits the floor, it loses shapes, but then it tries to go back to the original state. Pretty cool. Kind of looks like a condom. Cool. One thing that you might dislike on this simulation, on the basic one, on the first one, that after it hit the floor, you kind of see these stretch lines, right? This is because you have the stretch value way too big, and the struts and constraints are big too. Okay, so let's explore another value. I'm trying to show you how you can do easily the soft body, kind of like Cinema 4D, right? So again, wire those two outputs. And then on this one, maybe we are going to keep the stretch way bigger. Maybe, let's go with, I'm going with 1 million. Is this 1 million? Yeah, 1 million. And the strat, let's go with 50 and 1 by 10. So our constraints will really keep the sphere with the original shape. Let's add another 6 value on the X, so we can have all the 4 spheres. And let's see the animation. Pretty cool. More like a rubbery sphere, right? You can even increase this one. Let's go back. Let's make it really higher. And the struts, let's increase to maybe 100. And this one, I want the struts to not that big, maybe. Let me think about this. Yeah, let's try the bigger values. Let's increase these. Yeah, that way is going to behave kind of like that one. I like more the mid-turn. So let's try one thing with a lot of struts, constraints, and really low stiffness. Ooh, see? Now our cloth is stretching way too much. So let's increase the stretch. Stiffness, not like that. I don't want to stretch that much, but the Vellum, yeah, we can. Let's increase this to 2 maybe. Let me see where. On 4 it gets way too much. 3.5. And let's decrease this to 1000. Go up. Cool, cool. Like that one. I'm going to save that one. So let me add another one. As you can see, this is pretty damn easy to do, right? So let's go 24. So we have another one here. So on this one, I like the stretch. Oh, sorry, not the band, the stretch. Okay, I like that stiffness. But our constraints are way too low. So increase this to, yeah, 1e plus 8. Let's see how these behave. So this is the really basic stuff. Just by changing 3 parameters, as you can see, you can get really cool and different looks, right? So, another thing that you can do that is really basic, you can see that our sphere has really low resolution. One way to smooth this out is coming to the basic geo and then increase the frequency to 20. But this will really slow down your simulation time. Okay, so instead of doing this, of course you can do this if you have a really nice computer. Instead of doing this, you can smooth after the value simulation with the Vellum post process, right? So let's decrease the frequency back to, let's go to 12. A little bit higher than 10. Okay. So if I press play, let's go. It's a good one. Okay. Here you can see we have really low resolution on our sphere. And then you go to the export node, Softbody Vellum. On the Vellum post process, you can subdivide, or in other words, smooth the geometry, right? So let's go to Catmull and then increase this maybe to 3. Maybe 3 is way too big. But as you can see, now we have really nice edges, not sharp edges, and more smooth. Okay, that looks more like Softbody. Okay, pretty easy for this one, right? Let's cache this a little bit. Of course, the smooth while I'm recording is taking way too much. Let's decrease this to 1 for the purpose of this tutorial. And one thing that you can have, but in our case we don't need for now, but we have the detangle. Sometimes when the polygons from the sphere intersect each other and go outside, you can detangle so they won't cross each other. Okay, let's press play. Go to 90, see the animation. It is processing, almost there. Okay, so this one looks like a, a bag or something. Pretty cool, right? So by changing only 3 parameters, you have a really cool looking results and all different. Okay, this is the basic stuff. Now let's see how we can have multiple spheres inside another big sphere like I did on the example. and make them inflate like on Cinema 4D. If you have seen the iDesign CJ tutorial about inflate soft bodies, let's try that here on Vellum. Okay, so I'm going to create a new project. Let's save it, soft bodies to inflate. Okay, and again let's place a sphere. Let's dive in. I'm going to increase this one to 3. Okay, and let's convert this to ISO offset to have a volume. Right? Scatter, so we can scatter points inside the volume. Very cool. Let's have only 30. Okay. Let's place a sphere and copy 2 points. Very cool. That's why the first to the geometry we want to copy and the second the points. Now, as you can see, we have a lot of spheres with the same size. Let's change the primitive type to polygon. Okay, let's go to 10 on frequency, and I want a more random stuff on P scale. So you know I love vex. So let's place a point wrangle. Okay, let's do really simple stuff like P scale. Going to be a fit random point number. The random sends from 0 to 1, and then we want to have 2 channels for this. And a float max scale. Oops, I did something wrong. Wait a bit. Okay, and if I press this icon, as you can see, we have 2 channels. Okay, with this one we can control the scale of our spheres. So I have this really, and again, okay, now I have this messed up. Let's clear the interface. I'm sorry about this. Let's discard this. Oops, delete this one and move this up. Shaft. Okay, so we have the minimum scale, right, and the maximum scale. So now our spheres, our points, have random P scale between 0.1 and let's make 0.4. Cool, right? Let's place a null. Let's call base geo. Again, you already know how to convert these to Vellum softbodies. Select the node and Vellum start softbodies. Pretty cool. In this case, we want these spheres to collide inside another sphere, so let's place a sphere. Let's call it sphere collider. Let's organize this so we can see a little bit better what we are doing. Let me zoom in so you can see. We have our sphere collider, soft body. This is the export node and the dot network where the magic happens. So let's increase this one. We can have more resolution on this one. I think we are using 3 on that uniform scale, so let's put 4 on this one. So we will be sure that every single sphere is inside this bigger one. Let's hide this one and make this, select the sphere collider. Let's make a collision static object. You already may know that this is creating, press L to organize a static object, and our Vellum spheres will now collide with that bigger sphere. Let's hide this one. Okay. And we need to do one little thing. Let me remember where it is. I think it is on collision. Yeah. Because we are converting that bigger sphere, that big sphere, to a static collider, by default it is colliding by everything that's going outside to the inside, but we want the opposite. We want the spheres that are already inside and don't go outside, right? So instead of changing the normals, we can just go to static object and invert sign. So now if I press play, you'll see that our spheres will keep inside that bigger one. Pretty cool, right? So now our spheres are all the same size during the animation, right? And we want to inflate them. It took me a while to figure this out, but I read on the comments, not the comments, the docs from Houdini and Vellum, and they say to play with a value that is here. Let's go back to here. Not on Vellum cloth, I think. Yeah, just play with rest length scale. Instead of using that here, play here, I'm going to show you one other way to play with those parameters. So inside our DOP network, let's place a Vellum constraints property. Okay, so now you can see we have a lot of properties here. Let me increase this window. We have stiffness, compression stiffness, and we can control the constraints inside our DOP network. So let's wire this to the particle forces input, the second input of Vellum solver. And let's go to rest length scale. And they say on the documentation that if you want to inflate or increase the size of our Vellum objects, you can play with rest length scale. So let's change this to true, and you see something weird will happen, as you can already see this. Don't be afraid with that starting shape. It's normal when you fill up a balloon, you get this kind of wiggle surface, right? Because we are going to inflate our spheres. If we have the stretch on this cloth node really higher, we have the maximum volume right now, you'll see that we'll try to go back to the original state after a while. You can see going down. Okay, right now we are inflating our spheres, and then they are going with the gravity, they are falling down and colliding with the bigger sphere. Okay, one cool thing that CJ does on his tutorial is add a little bit turbulence to the movement of our spheres. So let's do that with our system in Houdini. One easy way to do that is changing the gravity. So let's place a noise field. Okay, wire that output to the data to attach on the gravity. Let's reduce the roughness. Increase the frequency, not 4, but 3 by 3 by 3. Minus minimum value, I want minus 10, minus 10, and minus 10 on everything. On the maximum, I want 10 by 10 by 10. Because I want some spheres to go to the right, other spheres go to the left, go backwards, go to the back, go to the front, top, or bottom. I want them to really move around as much as I can. So if I let this catch everything, you'll see that our spheres will collide and go bouncing and move all the way around with the turbulence noise. So let this cache a little bit and be right back. Let's check the cache system and let's see our animation with a little bit of noise. Cool. They are colliding with the outside sphere and with each other. This we can get a little bit collision. Here's we have so little spheres, but it is working. Okay. One thing that I didn't like is that after a while they don't look like soft bodies. Okay, so one thing I did is to decrease the stretch. Okay, so if I decrease this to 1000 on the cloth, remember this will allow the spheres to modify and stretch the surface. Sorry. So, and let me increase a little bit. Let me show you first before increasing the number of spheres. But you'll see that after they inflate, they will lose a little bit of the roundings form of a sphere, right? So you'll see that they are inflating, and then we have like these really cool cells. They look more of soft bodies now. Cool. So let's increase the number of scatters. Go to 50. And maybe let's increase the max scale. 5. Like that. Okay, I'm going to cache this system and be right back. And I'm back. I didn't have enough RAM for this simulation, so I added a file cache system node, with to cache my simulation. So as you can see, this is the final result. Pretty cool, because I lowered down the stretch stiffness. We get more these blobby and soft body shapes, more organic in my opinion. And you can see they are colliding with each other and then with the bigger and outside sphere. Pretty cool. Now, if you want to see how I render this animation in Unity, you can check out our Patreon page. This is the first one, when we explore the basic parameters to change our soft body behavior, right? And in this last scene, let me change the scene. How I got this really cool post for our Instagram. This is the same animation we just explored here. Okay. And I'm rendering in Unity. So we will have a real-time render. What that means is that if I press play, this is going to run 30 frames per second, and it is rendering the exact simulation. So I have an animation with 10 seconds, and it will take more than 10 seconds, but 12 seconds or 15 seconds to render out this animation with this quality. As you can see, I have everything here in Unity, post-processing, and those post-prod effects and color corrections. I have everything here in Unity, and I'm rendering these in real time. So if you want to see how it is possible to do that with Unity and Houdini, check out our Patreon page, because I'm going to do a series of recordings. Now every project I'm going to do for the Patreon or for tutorials, I'm going to render them out, Redshift or Unity, and I'm going to make a series of tutorials explaining how you can render that. And if you want to explore the real-time rendering, check out our Unity tutorials. So that is it for this tutorial. Now you know how to use Vellum to turn your models into soft bodies and make them change and deform the way you want. If you like this video, don't forget to hit the subscribe button and check out our Patreon page. The link is down below. If you want to learn how to start using Unity in your projects to render in real time, check out our Unity tutorials available on Patreon. I hope you enjoyed this video and learn with us. See you on the next tutorial, and have a nice day.